lesson and 1.3b are kind of review of parabolas. Now you spent an awful lot of time with parabolas last year, so I did them in separate things just in case you need to go back and look if there's one specific area of parabolas you had difficulty with. So both of these skills are things that we're going to need actually for 1.3. So first of all, the goal, I can state the vertex and axis of symmetry when a quadratic function is in vertex form. Okay, so we need it to be in vertex form in order to do that. So first of all, a quadratic function has a parabola as its graph. That's not new. The standard equation of the function is y equals ax squared plus bx plus c. Now that's not too useful for us for the vertex. So the vertex form is y equals a x minus p squared plus q. Now, depending on what textbook you used last year, this p and this q could be h and k. It really depends on the textbook which it is, okay? It's not so matter what letter it is, but actually the location, okay? And this form, this vertex form, is the converted form of the standard form. Okay, it's easier form to graph and it's called the vertex form, as I already have told you. So let's look at the summary of this. So again, this is something that you did last year. You did a lot of it last year. So first of all, the vertex of something like this. Now, hopefully you remembered that the vertex is the opposite value, opposite sign of what's in with the x. So it's going to be p, and it's going to be the value of the q for the y part. So the vertex is always going to be the opposite sign of the p-value and then the y value of q. The direction of the opening, how do I know whether it opens up or down? Well, remember that was related to that A. So the A is going to tell us whether something opens up or down. And we know that it opens up if A is greater than 0. It opens down if it is less than 0. So if it's positive, it opens up. If it's negative, it opens down. Now, axis of symmetry is if I took the parabola and cut it right in half, and it's this mirror image on both sides, well, that's going to be related to the x value of the vertex. Okay, so x equals p. So let's just look at a couple examples just so that we get this. So it says state the vertex, the axis of symmetry, and direction of opening. So here's our first one. And if we look at it, we can see that x hasn't been opened and there's nothing being added or subtracted to this. So in this case, it's very simple for my vertex. My vertex is going to be 0, 0. And I know that the axis of symmetry is the x value of the vertex, x equals 0. And does it open up or down? The 2 is positive, so it opens up. Okay, and if we go down a little bit further for the next one, actually I'll just get rid of that. So if we look at the next one, I can see first of all that I have something here. So the opposite sign, so it's going to be positive 3 is my vertex, and my y value, something's being added, it's a 4. And my axis of symmetry is my x value of my vertex, so x is 3. And then this time it's going to open down because a is negative 1, so I'm going to write down. And our last example. Okay, so my vertex this time, I see I have something with the x, so it's the opposite value, so it's going to be negative 2. And nothing's being added or subtracted here, so it's going to be 0. My axis of symmetry is going to be the x value, so x is negative 2. And does it open up or down? My a value is positive 1/2, so it's going to open up. Okay, so you should be able to watch another video tonight, and then there will be a worksheet that has both 1.3a and 1.3b on it. Okay, have fun.